We're going to consider three ways, as I stated earlier, about how to find the relative and absolute extreme values of a function. The first way we're going to find these is graphically, and that for our purposes will mean using the graphing calculator. We could be given a graph, but not nearly as likely. So graphically finding Extrema. Okay. So the idea here is, given any graph, I'll just draw, well, that's terrible y-axis, let's try it again. That's not very good either, but it'll do. So given any graph, let's do a quintic graph. So let's see, cubic. Alright. Given any graph, I can look through and find the extreme values, the extrema, by looking here. So I have two relative maxima. So these are both relative maxima. And in this case, I also have two relative minima. And I have no absolute maxima or minima because I have points higher over here and lower over here than my maxima and minima respectively. And I could say a few different things. So let's consider this extreme first. So if this were x naught, y naught, I could say that this function f has a relative maximum at x naught, y naught, or I could say f has a relative maximum value of y naught. The value of the function is the output value when x is x naught. So a few ways I could say that. I could make a similar statement about this first farthest left relative minimum. Let's just say that's at x1, y1. Same sort of thing. I could say that f has a relative minimum value of y1 when x is x1, or I could say f has a relative minimum at x1, y1. Now, there are lots of different cases for things that can happen here. Let me do a couple more, make some big splitting up. So, if I have an open interval like this, okay, so open from x naught up to x1, notice this has no extrema. I do not have a relative minimum, an absolute minimum. I do not have a relative maximum, absolute maximum. It's worth noting that if you have an absolute maximum, it will also be a relative maximum by the definition I go by. Some texts say they can't be, but in this case, no relative extrema, because I can get as close as I want to this y naught value from above, but there will always be something closer, and same thing for approaching this y1 value from below. So no extrema here. However, if I were to instead have one side closed and the other side open, you can see that in this case I still have what is a relative and absolute minimum, but no relative nor absolute maximum here. Just because it's an open interval does not mean that I cannot have extrema. I could have something that is maybe a piece of a quadratic here, and even though I have an open interval, you can still see right here that I do have still another relative and absolute minimum. Okay, and graphically now, how am I actually going to go through this process? So we can see identifying on here. If I want to actually do this now, that's the wrong thing to press. Let's try this again. There we go. So if I want to actually go through and do this, all I would need to do is first type in some function. So I'm going to just go through and I'll type in, I don't know, a nice cubic function that'll show some useful information. X cubed minus 12x. I'm going to graph that, and wow, let me change that to minus 3x. Make it a little bit nicer. Okay, much better. What I can see here is I have two relative extrema. I have a relative maximum up here. I have a relative minimum down there. And if I want to figure those out, well, let me zoom in a little bit to get it to see it a little closer. All I need to do is calculate. Second calc. I want to find the maximum. I could press 4, but I'm going to go down. The maximum, and it tells me I want a left bound. Well, okay, the maximum's over here. Let's go over there. Okay. And I know that this point is farther left than my maximum. I'll press enter there. I need a right bound. That's the next thing it tells me to find. So I'm going to go over here. And I know that that point is farther right than my maximum. And I need a guess. So I'm going to get as close as I can to that maximum. Press enter. And it will tell me that I have a relative maximum at -1, 2. Or I have a relative maximum of 2 at x equals -1. I can go through the same process with the minimum over here. So that's how I would work this out graphically.